Okay, so why don't we do something kind of similar to last week we did? Last week we find out some of the average grades and so on to we added grades to the list box, and then we find out the total grades and the highest grade and so on, right? With the do loop and while loop. Okay. We can add some data here, but instead of having a loop to generate the data, we could add some data. We ask the user to input some data into the list box here. So I'm not going to put an input box here, but we'll prompt for a user input box, and then we'll keep adding data to the list box, and then we'll also ask the user to terminate the loop when they enter a certain value. Okay, so that terminating value is called the sentinel value, and the sentinel is for example, let's just say we add some number, and you can say enter a -1 to stop. Okay, so that's the sentinel value here. So I'm going to modify this list here for this example, and let's remove all these here for now. Well, I'm just gonna highlight these and then comment these out. Okay, so I'll do it like right down here. So we want to prompt the user to enter some data, and we'll do that using a loop. Okay, I'll use the do loop, the while loop, which you kind of review for what we did last time. Last time we talked about the two different types of loops. We call those the pre-test or the top control loop, and the post-test or the bottom control loop. What does it mean when I say a pre-test and a post-test? Does anybody remember what they are? Why we call those pre-test and post-test? So the for loop is always a pre-test, okay, because we test the condition here at the top. Although as you can see, it's like 1 from 100 down to 90. This is really the condition we're testing. We're testing that whether we start at 100, that means that is it greater or equal to 90, right? If it is, then we would follow through and then execute the code in the loop. And then next we'll decrement it by 1, and then 99 is less than or equal to 90. Yes, so we test the loop here on the top, okay, until the loop is no longer true. I mean the condition is no longer valid, and then we exit out. Okay, that's the top control. The bottom control is we test the loop at the bottom. So a for loop would never test the condition at the bottom. They only do that with the do loop. Okay, so when you ask the user to input something, and let's just say that we want to have a number, just input some number, and this will be just integer number. Okay, and typically here you would say something like what do you say here? We'll say num equals input box, right? And then we will specify the so you want to also add the information to the user so they know what they're supposed to enter. You can put a message here, just say enter you know, a positive number, okay, and you can put here enter -1 to exit or quit. Okay, so if you enter a -1, then that would terminate the loop. Otherwise it would just keep going, right? Okay, this is what we want to do. Actually no, I don't have the semicolon here. Different language. So I'm going to ask the user to enter a positive number, enter a negative number to exit. Okay, if you don't put a loop, then just do one time, we're done. But if you want to keep entering this until the end of that loop, then you want to wrap this inside a loop. Right, so you will say here, you would say something like do, right, while, and number is, you can say either like a not equal to 1 right? Not equal to 1, I mean minus 1. You can do that. If it's not equal to 1, that means a negative 1 means that it's a different number, so you keep adding. But just in case, if it's a negative number, and then we can force the negative number to also be to cause the loop to stop, we could say like as long as number is greater than a negative 1, or maybe then of course we assume that we don't also 0, right? Then it will always be in the loop. So let's just say that it's not equal to 1. Okay, because and we'll just be nice. We're not going to enter any negative numbers. So as long as it's not a negative 1, then you keep adding that to the loop. So the first thing is you issue that. So the first number, and you check it. If it is not a negative number, then you add that to the list. So LST data, add that first number to the list box. Okay. Then after that, as you can see, we have to call this again. We have to call this one more time inside the loop. Okay, and then the loop starts here, and then it keeps adding until we have a negative 1, and then we exit out of the loop, right? And let's just say we stop here for now. So I will click start, see if this works. We'll say start here, so we ask for a positive number. I put in 12, we add 12 to the list. As you can see, ask S again, enter another number, put 24, and then whatever that number is, and then finally we put the minus 1, and we exit out the loop. Okay, so we stop the loop. So that works fine, right? And you keep going until they enter the negative 1. If they don't, just keep going forever. Okay. Now, any questions how I set this up? Okay, notice this line 14 and line 18 here. They're exactly the same thing, right? The same statement. So I'm writing it twice. So this is a redundant code. And because we're testing the condition at the top, you have to know what this num is. But in order to do that, you have to read it first. And after that, you can do it again. Okay, so this type of loop is a really good candidate for what's called a bottom test loop. Okay, because why don't we just do this first, and then do one time, and then we don't have to put that outside in the list here. So what it means is that you could do something like well, you add a number, yeah, I mean there's several ways to do it, but I was going to say that you could repeat this, you can remove this, and then ask the question down here, and then if it's not a -1, you can add it to the list. So you could do something like, you can rearrange this a little bit so that you don't have to type this line here. It will be like so if you remove this while, right, to the bottom down here, and now you have a bottom tested loop. Okay, and then you would actually call this first. Okay, you would ask the information first, and then before we add this to the number, we have to make sure it's not a -1. a little bit of coding. We can say if num is not a -1, then we add that to the list. Okay, and in this way you don't have to ask that twice. So when you run through this, because it guarantees one iteration through, you ask for the input. If it's not -1, we add that to the list box, and then we check the condition at the bottom here. And if it is true, while num is not equal to -1, then we go back to the loop, and then we keep doing that loop here again. So this one here guarantees us to run this loop one time, and we only put the number if it's not -1. So remember, this is the do while loop. Okay, the other part is the until, right? So the do until is a little bit different. Just make sure that you do the until. What is the opposite of not equal here, right? So if I were to run this again, it should still work just like before. Okay, so if you put 12, 13, -1, okay, it exits out the loop. Okay, so this is a do while. This is a post-test loop. We test the condition at the bottom. So the do while is a positive test because we're testing that this is positive, right? True. Well, this is true, then we keep running that until it's false. If you use the until instead, now if you change this to until, you have to remember to also change the operator here, the opposite of what's not equal to. Equal, right? We'll keep looping this until the number equals 1, a -1, then we quit. Okay? So don't confuse with these two here. If you put like it was before, is a loop until a number is not a -1, then of course if the first input is not a -1, it will exit out already, right? Because it's not -1. So it's a little bit tricky when you do that. So just make sure you put equal here, and then I think even I get confused sometimes. So let's see, put 12, 13, and you put until it goes -1, and then we stop. Okay, so just make sure you put that there. If I don't put it, if I put it just before, you'll see that you might run into, put let's just 12, then it stops. Okay, because it's already true, it's already false. Now it's not equal to -1, yeah, then we exit out. Okay, so it's a little bit tricky when you use the until and then the or the while. So just make sure you switch the operator here. Okay, so we enter some data, some number into the list through this option here, and then let's just say that in that current list, how many ever numbers there are in that list box, we want to find the largest number out of that list. Okay, so what is the algorithm to figure out the largest number in that list? Let's assume that we enter more than 2 numbers. Okay, so we don't know the number of items in there. You could always find out the list box items dot count. Okay, it will tell you how many elements are there in the list box, in the current list box, and then we'll loop through the entire list from 0 to the index number to count -1, because it's a zero-based language, and then we'll check every number, and we'll compare the first number with the previous number, and then to see if that is the largest number. If it is not, we just skip it, check the next one. If it is larger than the previous number, we'll set a different counter to store that large number, and then we keep doing that, right? Okay. So we want to have the total number of items on the list. So let's just say we declare another variable called, let me just call it max items, or max count is fine, right? Max count as integer. This will be equal to the list data items that count. Okay, so this count method here will tell you, I'll show you this look like that, will tell the number of items. In the list box. If there's 10, then that'll be 10. But that is not the index number. Just make sure the index number is always the count minus 1. Okay. So now we know the number of elements, and we can always check, right? You can say if max count is greater than, we just put 1. Okay, if it's 1, then that's already the max number. Let's assume that it's greater than 1. You only check when it's greater than 1. Otherwise, there's no point. So, what do we need here? We need a variable to track the current number, because when we look at the list, it's going to be that first item, right? It could be that number, it could be the largest number on the list. We'll assume that the list is not sorted. If you sort it, that's kind of cheating, but if you sort it, it's always going to be the largest number already. So assume it's not sorted. Okay? And you can sort it also, by the way. So we need a counter, a number. So I'll put outside here. We'll dim a, you could say largest number. This will be as integer. We'll assume this largest number is 0. Okay, because let's just say that's given. That is the largest number. Anything larger than 0 will be the next largest number, right? So we're going to compare the first item on this list box and compare that with the current largest number. If it's greater than this 0, then we'll reassign the largest number with a new number, right? So I would say if the LST data dot items, okay, to get that number, the first number, you usually will say item of I, right? Which I don't have here yet. It will be I. Like, so for the first number will be 0, right? If, for example, if 0 is greater than, you can say greater than the largest number. I'm just trying to put the algorithm here. If that is true, then the largest number will become the LST data dot items of 0, right? If that is true. Otherwise, it will just move to the next number. But this is, we're just hard coding the first element. And then that means if this is not true, then else if items of 1, else if items of 2, and so on. So that's not gonna work. So that's why we need to put this into a loop. Okay, we'll wrap this inside a loop. And since we know the count, you can use a do while loop, we can use a for loop. Since we're using the for loop, let's use the for loop to do this problem. So we will say for I, starting from the 0 position up to the max count, minus 1. Okay, make sure max count is the total count, but the index position is always minus 1. So if it's 10 item, it's going to be from 0 to 9. And then we will end that loop here with the word next down the bottom. So we wrap that inside the loop. Okay, so you start from the 0 number to the number of count. And then here, instead of hard coding this constant number, we put I in here. Okay, so it'll be the ith position. If the first number, which is 0, is the largest, then they'll be assigned the largest. They move to the next one, which is the second number. Is it larger than the first current largest number? If it is not, then we're not going to run this statement. We ignore it. We move to the next item in the list. And then finally, we'll get the largest number, which is n, when we complete the list. And then out here, once we're done, then we could say, maybe out here, we'll display that to the form. So let's just go to the form and add another field, so we can print that out, like maybe over here. What should we add? We could add a label field. So let me get my toolbox back out, and we'll add a label here. Okay, I'll put it like right here, and I'm gonna get the properties. I'll make that label will be, let's make the font a little bit bigger. Let's just put no, yeah, 20 is fine. 20. The name will be LBL, largest number. And the text will be like largest, well, we'll leave it blank, right? So if you do this, it'll be just blank. It's there, right? Until we added the text, we'll see the largest number there. For now, let's say we leave it blank. It's there somewhere. Okay? And then, so back to our code. And then now we just basically display that to the largest number.text equals the largest number. That is our largest number. So we do everything here in the code. When we click the loop button, it will prompt the user to enter some number, and it will loop through the list box to find the largest number, and then display the largest number in the label field called largest number.text number, and then we're done with that loop. Any questions how this was set up? Again, this is just one way to do this. I'm sure there are some other methods as well. Okay, so let's run this application and see if we can have something here. So I'm going to go to for loop, initiate the event, put as a number, put 12, put 55, 34, 3, and just put no more. Let's just say 45. And then we need to terminate this with a -1, right? So the largest number will be 55. Okay. So here's the largest number is 55. And notice the text just says 55. What if we want to say largest number and then it's 55, right? You also want to put the text there. But if you keep adding that to the list, if you go and add some more, 333, and then 444, and then if you put -1, now the largest number will be 333, right? It's still running, so the list will still be included in here. When we click the loop again, everything's all over again, but the data will still be existing inside this list box. We're just adding it again. It will rewrite or reloop through the entire list box with the new numbers we added, and then of course will be displayed here again. If you loop it through here, if you don't add any more data, you just put -1, then we just get the same current number, right? Okay. Any questions how this was constructed? How we tackle this problem? If you want to look for the smallest number, same thing, right? Just basically switching this to a different sign. If it's less than that number, then you update the largest number. It's called largest, but it could be, it's just anything. Okay. Okay, so let's just say that we found the largest number, and what if also we want to check if that largest number is an even number or something. We say largest number is even or is odd or is not even, right? So we would do that inside here, right? So the largest number is that, and then of course you can test it down here one time, which is I think probably easier. You could just test it and say if largest number, mod 2 is equal to 0, then it's even. I think that's pretty easy to do. Right, so you could say like if largest number, okay, mod 2 is divided by 2 is equal to 0. That's a positive, is an even number. If that's the case, then you can say largest number, okay, and you can say this is positive, is even, right? And you put the else here, and then just copy this again, put here, and if, and then it's odd. Right, just simple like that, right? And of course you can maybe add more text in front to say, largest number is, and then append that, right? It's 55, maybe, and it is even. Maybe that makes more sense. So again, this is how you would basically structure your code, and you can always refine it, because any redundancy in your code should always refine it. So you can see this is redundant. This line here and this line here is redundant, right? The same text stuff here. I could make this more efficient. Okay, so but anyways, to see if that's the case, we can add some numbers, 12, 33, 4, 43, whatever, some number here, and then we put a -1. We'll say out of space here. So so 42 is the largest number and it is even. Okay, and if I add it again, I put like 55. We'll say, and then -1 to stop it. I say 55 is now odd. Okay, so pretty easy to do that one. Okay, any questions on this demo here? Why don't we do problem number, which is kind of similar to the homework assignment. We'll do number 27, chapter 6 on page 252. This is to find the greatest common divisor. Okay, so let's see if I can go in there. It's 252 in the text. So this one here, this flow chart. So now we're given this flowchart to help us code. So we are supposed to find the greatest common divisor, that is the largest integer that divides into both two numbers. So if it's, for example, if it's, this is your homework assignment here. So if it's 30 and 35, then the greatest common divisor in both cases will be 5. So 5 can divide into both of those numbers. Okay, if it's 36 here, then the greatest common divisor will be just 1, right? Because you cannot divide, oh no, it would be 6, right? Yeah, if it's 36, it would be 6, because 6 can divide into 30, and 6 can also be divided into 36. If it's 37, then yeah, that would be 1, because there's no other numbers can divide into 37 other than 37 in itself. So let's do that assignment. Let's build this little application here. And so we have basically just two labels on top, 2 numbers, a button, and then the GCD at the bottom. So we have 3 labels, 1 button, and 3 text boxes. Okay? So why don't we create a new project? I can do that. I can save this one here. I'm going to create a new project. And this is chapter 6, number 27, is it? 6, yeah. GCD. It'll be 27, and then I put GCD here. Greatest common divisor.